Hey guys, so this is the beginning of the review. Who knows if I'll make it all the way through or not. Let's give it a try. This is 5-1 and this is always tricky. This is the rules of exponents and they are just picky, so that can make it harder. So keep in mind that a power, this thing is the base, this bottom, well, I don't use it for, I was looking at the first problem, sorry. You're gonna have base raised to a power. And the base is the thing getting repeated and the power tells you how many times. So the rules only apply to those powers. They're exponent or power rules. So for example, here in number 1, this means that I'm going to have 4 repeated 3 times 4 repeated twice. The other easier way to come up with the fact that there's going to be 4 to the 5th power is simply to add those powers, 2 plus 3. And then you would go to that pink chart that I made you, because that's a number base. When you have a number base, you should actually find the value for it. Here, if you remember, I do 4 steps, and the first thing I look for is distributing a power. Powers only multiplied by powers. So 4 times 3 and -5 times 3. But the second thing I do is move negative powers. If they're on the bottom, they move to the top. If they're on top, they move to the bottom. This doesn't have a bottom, but it does now. So that a to the 12 stays on the top, b to the 15 moves into the bottom. And when you think you're done, always make sure that you don't have any repeated letters. I have an A and a B. I don't have A written twice or B written twice. I also check for no negative powers. We didn't really do these in class. I don't love this problem, but this is a number, so treat it like a number. 14 divided by 7 is 2. Here, these are the same base. So you would move these two up here. You'd end up with a 10 to the 6th next to a 10 to the 2nd. So you'd end up with 10 to the 8. Which is different than the answer key I'm seeing. So I'll post this answer key. Here I'm going to distribute again. All the powers multiply by that power on the outside. And be careful here. A -4 times a -3 is actually a positive 12. And on the bottom, a power of 6 times -3 is -18. So this is negative and has to move to the top. Since it's moving to the top, you don't have a bottom, and so it disappears. And again, I don't have negative powers. I don't have repeated variables, so I feel confident about my answer. Now here, I always throw down a power because it's really easy to take that -3 power and multiply it by the -3 number and put -9, but that's not how it works. This power is only going to multiply by the powers. So I get 3 to the -3 because that -3 multiplies by the 1 that was invisible. -3 times 4 makes that to the -12. And -3 times -2 actually turns positive. So now the things that have negative powers are going to move into the bottom. That's not there, but now it's going to be there. So the y to the 6th stays on top. 3 to the 3rd moves to the bottom, but 3 to the 3rd, if you use your pink card, is going to be a 27. And then the x to the 12 moves down. So you want to leave, like if you have a 3 to the 3rd, you need to use your pink card and change it. Since the base is a number, you can actually get a value. These are currently both to the 1st power. So again, writing that number 1 in helps me remember that the 3 doesn't get multiplied by the -2, just its power of 1 does. Same with this 4. But now they're both negative, and so they're going to have to move. The 3 is going to move to the bottom, and the 4 is going to move to the top. When they move, they end up with a positive power. I think I'll just write that on the answer line. Because the 4 to the 2nd will move to the top. 3 to the 2nd will move to the bottom. But I go ahead and check my pink chart, 16 over 9, and that doesn't reduce or anything. So that is my final answer. Number 7 does not have parentheses. And so what I do is I kind of just look, 2 and 6 are numbers, so I'll deal with them. Here are my x's, and then here are my y's. So I'm going to move anything that's negative. So just this has to move into the bottom and just this has to move into the top because they have negative powers. So the 2 stays, the y to the 5th stays, but then the y to the 2nd comes up from the bottom and becomes positive. On the bottom, the 16 stays. That x to the 3 that was there stays because it had a positive power, but the x to the 6 moves down. Now these are neighbors. These, like if I wrote this as my answer, I know it's wrong because if I said it out loud, I have y to the 5th and y to the 2nd. You're not supposed to have the same letter written twice. So this reduces like it has since, I don't know, elementary school. So you get 1 over 8 because they can both divide by 2. My y's would go together to be a 7 power, and these are neighbors, so they would go together to be a 9th power. You don't have to write the 1. It's not wrong if you do. It's not wrong if you don't. So this is where I would end up. Also different from the answer key. Okay. So this one, my dog's going to drink really loud right next to me now. It's always something. And this -3 times 2 becomes a -6. I'm going to move this down. So I end up, they have the same base. So I have a 3 to the 3 that stays up here. A 3 to the 6 moves to the bottom. So looking at these two powers, the difference between them is 3, but the extras will be on the bottom where you had more to begin with. So I end up with 3 to the 3rd on the bottom. These are canceled out. But then I use my pink card to find out, or my pink chart to find out that that's 1 over 27. Okay, so that is the end of 5-1, and I apparently have to let my dog out because now she's scratching at the door. So that's annoying. Maybe she's going to go lay down. Okay, I think I'm going to ignore her for a little bit. Decide whether the function is a polynomial. So keep in mind you're looking for weird stuff like negative powers, fraction powers, square roots, that kind of thing. If it is, write the function in standard form. Keep in mind that means high power to low power. And state the degree that means the highest power. Type, that's going to be linear, quadratic from the chart in our notes. And leading coefficient, that means the number out front once you've changed it into standard form. Okay, excuse me. So looking at this, this is problematic. So that is not a polynomial. So really, in essence, the rest of these don't make any sense. You're asking polynomial questions about something that's not a polynomial. Here, there's nothing weird about this, and so this one is a polynomial. Writing it in standard form, it's highest to lowest power, and there's a constant at the end, so that's good to go. So this is what I use. My degree is this highest power, so that's going to be 4. My leading coefficient is this number out front, so that's going to be 5. And the degree tells us what type it is. If you look back at your chart and if you want that information, you're going to need to put that onto your note card. And that type is going to be quartic because of that 4th degree. Evaluate, remember that the root word of evaluate is finding the value, and that finding the value means you are plugging in a number. So the other way they're going to write this is going to be f of -3. That means the same as plugging in -3 for the x's. You really have to be careful with what you type in. You have a -2, that's part of the rule. You cannot change the rule. And then in parentheses, you put your -3 and then do whatever you're supposed to do to it, cube it. Then the rule says to add 3, and then where there was an x, put your -3 in parentheses. And then the rule says to -2. So it's really important that you kind of use those parentheses, especially when it's a negative. I am just putting this through. I know the answer key has an answer, but I want to double check it. Okay, I got 43. Here I'm putting in a 4, so the test will say f of 4. So everywhere there is an x, you're going to put in a 4 and do to it what was getting done to the x at that part of the polynomial. So in the polynomial, it got cubed, squared, and then plain x. So it got cubed, squared, and then plain in here as well. I'm going to assume this one's right on the answer key and grab 185. Check it out on your calculator though, because you want to make sure you can get that. Because the negatives are tricky. Okay, I love end behavior. It's so logical. I just have to remember it. This is going to be your red chart. Describe the end behavior by completing the statements and sketching. I'm not going to sketch. You aren't going to have to either. So keep in mind, this is the y-axis, and this is up, positive infinity, and the y-axis when something's going down is negative infinity. This end is the left end where x's go to negative infinity. This is the right end where x's go to positive infinity. So just kind of keep that in mind, that it's just about thinking through up, down, and whatnot. So first of all, this is in standard form. This is my highest power. The degree is 3. That is odd. That tells me the left end will do the opposite of the right. So then I look at my leading coefficient, which is -5. The fact that it's negative tells me that the right end will go down. The leading coefficient always tells you what the right end is going to do. So if the right end is going to go down and the left end from up here is doing the opposite, it is going up. So now just know that as you try to write it in this new fancy language. When it asks you to talk about x going to negative infinity, think about what that means. That's this end. X is going to negative infinity. So it's asking about the left end. The left end is going up. So how do you write up? Well, up is positive infinity. So positive infinity. Down here, x going to positive infinity is over here. So they're asking about the right end. We already know the right end is going down because it had a negative leading coefficient. And so down is negative infinity because this is up, down. Okay, so this one is standard form already. On the test, you have to look and see if it is before you start. It has a degree of 4. I don't care that it's 4. I just care that it's even. Even tells me that the left end will do the same as the right. Looking at my leading coefficient is 3. I don't care that it's 3, but I care that it's positive because that tells me the right will go up. So if the right end's going up and the left end is doing the same, then the left end's going up as well. So both the left and the right end are going to be going up, then they're both heading towards positive infinity. I don't really care if you put the positive sign or not. Okay. This is kind of funky monkey. This is going to be for this page, I guess. Give the coordinates of the relative max and mins. So these two are going to be like x, y points. Keep in mind that a relative max is like a peak where the graph goes up and comes back down. And then relative minimum is like a valley where the graph goes down and comes back up. So it has to have that turn or that curve to it. All right, so let's give this a little try. This is going to be, now keep in mind, if there are other points that are highlighted, it doesn't matter. I only care about the ones that are peaks or valleys. So this is going to be a max, and a min. The minimums, watch for that because I think on the test the maximums come first. The minimum is right here and the coordinates for that are -1, 1. Hopefully that's not confusing because that's something from a long time ago. Relative max, there's one at -1, 2, 3, up 2. And then there's one at 1, 2, 3 in a positive direction, up 1, 2, 3, 4. Okay, Now, it's important as you go into these intervals next, the increasing, decreasing, to keep in mind that you only use the x values from those 3 points in your answers for this bottom part. Now, from left to right, you get on this graph from the left, you're going uphill, then you're coming downhill, then you're going uphill, then you're coming downhill. So decreasing is going to be downhill, increasing is going to be uphill. What I like to do so that I don't get tempted by the y's is I just draw a line down through this max, through this min, and through this max, because those are the places that the graph changes from going up to down, down to up. And then I write in. The far left is always negative infinity, and the far right is always positive infinity. This first line going through the farthest left maximum is occurring at -3. This next line that's occurring at the minimum is at -1. And the last line over towards the right is going to be at +3. And now I know that I'm only using these values to describe what's going on in between each of these changes. The yellow part here is going up from left to right, coming back down, going back up, coming back down. So increasing and decreasing. So the places that it's increasing are the far left piece, which goes from -infinity to -3. So these are not points. These are what we call intervals. And it's always the farthest left x and then the right x, like where you're going from and to. So I would be like, okay, this graph is increasing from -infinity to -3. It's also increasing from here to here. So that's -1 to 3. Where is it decreasing? Well, in the 2 pink spots. So that's between here. So that's from -3 to -1. I'm just using these numbers. And then it's decreasing again from 3 to the right end. That is a tricky concept, and that is brand new. You've never done that before, so make sure that you get some help if you need help with that. Okay, so I think this is what they're calling the max, which I'm not sure, it's kind of a stretch, but we'll go with it. So this is my max, min, and then this is a random point. That is not a max or a min. It is not changing direction. Here's where it's going up, and here's where it's going up. Here's where it's coming back down. Max and mins are only at places where it changes direction. So here and here. So my minimum is at over 1 down 2, it looks like. And my maximum, it looks like, is back 1, up 1. I'm like a lot confused about why this is down here. So anyway, we'll go with that. And then I need to think about my intervals of increasing and decreasing. Okay, so I'm going to write out my x's down here. Far left to this line, which is at -1. This line's at +1, because remember, I'm only using the x coordinates of those max mins. And then the right end's going to be positive infinity. This part is increasing, so is this part. This part is decreasing in between. So for increase, I'm going to increase from -infinity until I get to -1. And then again from 1 on to positive infinity. The only place that it is decreasing is in between these two. So from -1 to +1. Okay, so that was a lot. This was kind of, if you're looking back through your notes, 5.2 day 1. And then all of this stuff is the red chart from 5.2 day 2 if you need more help or a video or notes or something. Here we're just going to be doing math. We're going to be combining like terms. That's all this means. being really careful if there's a negative like here that it gets distributed. And then product's always tricky because that means we're going to have to do some pretty big multiplying and kind of keeping track of that. So let's just hustle through that and then you'll know everything in the whole universe. Okay, so this negative is going to affect everything after it. It's like distributing a -1. So I have this out front, but this becomes negative m cubed. This becomes negative 4m squared. These negatives cancel for a positive 9m, and these negatives cancel for a positive 2. Now go through, find the highest power of m, which is third. Find all of those. So 6m cubed minus 1m cubed leaves you with 5m cubed total. Now go through and find if there's any of the next highest power, which would be m squared. There's only this minus 4m squared. It doesn't have anything to combine with, and so it doesn't change. Then any plain m's. There's 9, but nothing for it to combine with, so just plus 9. And then lastly, any numbers. So these two are alike. -5 plus 2 is -3. This is my answer. It should be in standard form from the highest power of x on down, ending in a constant caboose. Okay, same thing here. I'm going to write out everything before it. Ugh, I don't like s's because I can never write them neatly and they look like 5s. Now this negative is going to cancel that negative, making it 2s to the 4. This negative is going to make this 8s to the second. These negatives will cancel, and these this negative times the positive will become a -2. Oops, sorry. Okay, so then now that we distributed the negative, let's go through, find the highest power, which is the fourths. So I get 5s to the 4. Now I'm going to go through and find my next highest power, which should be to the third. But that's the only one. So -2s to the third. Wait, I wrote 5 plus 2 is 7. Excuse me, I wrote 5 plus 2 is 5. So that was wrong. 5 plus 2 is actually 7s to the 4. Brain fart. Okay, then let me find any s squareds. I only have this term, so -8s to the second because it doesn't have anything to combine with. Now I'm going to go hunting for any plain s's. I have this one. Oopsies. That was not the highlighter. So I'm going to have just that plus 1s. And then any numbers. And the only numbers that I see are plus 9 and -2. So 9 minus 2 is going to be a 7. So again, it should always end up in standard form when you go to write your answer, and you want to write your answer in standard form on the test as well. It's really just hard to keep track of stuff. So the better you write it out and kind of cross things off or highlight or color as you go, the easier it is to keep track of everything. These are actually going to be a little bit easier because this has a plus sign, and a plus sign doesn't change the numbers. So you can just start combining like terms right from the get-go. Start with the highest power you can find, though. The highest power I see in the Q's is the to the third power. Be a little careful. Use your calculator if you need for confirmation. But -3 minus 8 more is going to be -11 Q to the 3. And I'm not changing any signs because this was addition from the start. Now I'll go through and see what I can find for Q squareds. That's the only one I see. So the plus 5q squared goes next. Then I'm going to go through and see what I can find for plain q's. 7 and a -1. So if you think of that as 7q minus 1q, that's going to put you at 6 plain q's. And then the only thing I have left is this 16. I don't have any other plain numbers to mix it up with, so that stays as its only constant or caboose. All right, easy McPeasy. That's got a plus sign. I'm just going to go for my highest power of ZXPQ, whatever they're using. The highest one I see is z to the 4. And so I have -4 and a +1. So -3 altogether. I'm not changing the powers on these because I am simply collecting like terms. I'm saying -4 plus 1 is -3 of those. Now I'm going to hunt around for any z to the thirds. I only see this -1 z to the third. Then I go back looking for any z squareds. All right, well, there's only one of those. So plus 3z squared. Then I go back and look for any plain z's because I've gone 4, 3, 2. So now z's to the 1 power. The only one I see, plus 6z. And then last, I go hunting for my constants, just plain old numbers. And I have a -9 and a +11. So that's going to turn into a +2. Okay. Product means I'm multiplying, and this is where the powers change because you're going to be multiplying them. So keep in mind, if I have x to some power and I multiply it by the same base to another power, I actually add those two powers. So here I'm going to distribute. 2 times 5 is still 10. This x is to the first power, so an x to the third times an x to the first will result in an x to the fourth. And then 2x times a -1 is just -2x cubed. I should have said 2x cubed times a -1. All right, here I can see that I need to FOIL. So first is g times g, so g squared. Then the g gets multiplied by the -2. Then I need to multiply the 9 times both things, so plus 9g, and then 9 times -2. In FOILing, it's very common for these two to combine. So I have a g squared. These two, -2 plus 9, turn into a plus 7g. And I don't change the powers because at this point I'm just combining like terms. And then minus 18, which I can't combine any further because nobody has the same power now. And that's in standard form. G to the second, then g to the first, and then my constant. Okay, this is tricky and everybody loves to do this wrong, so don't. This means 4t plus 1, and then you multiply it by this. Watch for this on the test. You do not distribute that because that is multiplication that allows us to distribute. This little plus sign in the middle means that you cannot distribute that 2 to both parts. The only time we distributed those was way up here if we had a power on the outside, but everything inside is multiplied together or divided, like here. When you have a plus or minus sign inside, you have to take that whole thing, 4t plus 1, multiplied by itself, because the whole thing is the base. And then I have to FOIL. So 4t times 4t is 16t squared. 4t times 1 is 4t. On the inside, that 1 times 4t is also 4t, and then 1 times 1 is just 1. So like normal, these two go together. They don't cancel because they're not opposites. There's actually both positive, so I get 8t and then plus 1 at the end. That's going to be a really easy and very popular one to get wrong. So make sure that you watch for that kind of like parenthesis squared. That means you're going to have to write whatever's in the parentheses and multiply it by itself. This is a doozy. This is 100% on there. And we did these in class. And so I'm going to do the way that I did in class. I write the terms of the big one across the top and kind of put each one in a column. And then on the side, I write the terms of the smaller one in columns. So now in this first spot, I'm going to take n times 2n squared. And that's going to give me 2n cubed. Then here, I'm going to take that n times negative n and get negative n to the second. And then I'm going to take that n, oopsies, and I'm going to multiply it by this negative 7 and get negative 7n. I keep changing the wrong thing. Now in the bottom row, I'm going to go ahead and I'm going to multiply this 5 to this first one, and in the box between them, I'll get 10n squared. When I go back to do this 5 times the middle column, I get negative 5n. And then when I finally go back to do this 5 and the negative 7, those will turn into a negative 35. Now, if you do this correctly, you want to be able to see that these diagonals are the same power. It'll make it easy to combine like terms. So I start up here in the top left, 2n to the third. In the second diagonal here, 10n squared minus 1n squared will be a 9n squared. Then here, these are alike. Negative 5n minus 7 more n is negative 12n. And then you end down here in the bottom with that caboose, that constant, the number that doesn't have a letter. So practice that. If you don't feel like you know how to do it, that's something that's going to be on there. You want to practice it in your homework from that day. All of this is in 5-3. All right, this one's hideous, and it's the grand finale. Much like this problem up here, this one means that you take 2f plus 1, but you multiply it by itself 3 times. So I'm going to FOIL these two. This is going to give me 4f squared plus 2f. On the inside, I get another 2f, and then 1 times 1. If you're still struggling with foiling at some point, that's just a thing you've got to figure out. Okay, so that much is the answer to 2 out of the 3. So this one comes back down. And so now, like, number 21 is kind of a combination of 19 and 20, because now what I got to do is take these terms and write them across the top. And then I'm going to take my 2f and my plus 1 and write them across the side. And then when I go to fill these in, these two will make 8f cubed. Here in this box, I'm going to be taking 2f times 4f, so 8f squared. Now I'll be taking 1 times 2f, so just a positive 2f. In my second row, I have 1 times 4f squared, then 1 times 4f, and then 1 times 1. And again, I feel pretty good because these are the same and these are the same in terms of powers of f. So I always start up in the top left, negative 8f to the third. Here I'm going to have 4f squared plus 8f squared, so 12f squareds. And then my next diagonal is 4f plus 2f, so 6f. And then I end in the bottom right with my little caboose or constant, and I'm donezo. So be proactive, you guys. If there's a part of this that you don't understand, 5-3 is the adding and the subtracting and the multiplying and foiling, distributing. 5-2 day 2 is the graph stuff and behavior, basically all the things that are on that red chart. Here, this was 5-2 day 1, where you practice learning if it's a polynomial or not, what's the degree, leading coefficient, and how do I find a value. And then up here, this is all 5-1, which is your exponent rules. So anything that you want, put it onto your red card, and then your red card is going to be the resource that you have to be awesome and get these all right. Have a great day. Bye.